Alright, in section 3.7 we talk about introduction to modeling. And what do they mean by that? What they mean is they give you some points and they ask you to come up with what you think to be the equation of a line. And sometimes the points line up exactly and you can find the exact answer. Other times you can't find an exact answer and they sometimes ask you to approximate. It depends. In 3.7 plus, the section after this one, you'll be asking your calculator to find what's called a best fit approximation, where your calculator will take in the data points, the points you type into your calculator, and it will find a line or a quadratic for you, and you'll be able to just look at the numbers that your calculator tells you. But for now, in 3.7, you're asked to do it by yourself. Alright, so example 1, it says determine whether a model is exact. A person can vote in the United States 18 or over. The table shows the voting age in millions. Does the population this model the data exactly? So if you plug in 2006 for X and you subtract 52,991.5, do you get 225? And then same thing for 2008 times 2.75 minus that, do you get 230? Same thing with 2010 times that minus that, do you get 236? Well, for the first and third one, you do get the same exact answer, but for the second one, you don't. When you plug in the second one, you get 230 and 230.5, which is not exact. It's close, but it's not exact. Okay. Example 2 shows the mileage on an SUV. Okay. And after 2, looks at Y is the number of miles traveled and X is the amount of gallons burned. So after 2 gallons is it takes you 2 gallons to go 30 miles, 4 gallons to go 60, and so on. And so you got these numbers here, and if you draw a line, it hits every single point smack dab on, doesn't miss a point. And so that's exact. Okay, so plot the points and sketch a line and use a ruler, and you find the equation of a line, and you can find the equation of a line using any 2 points you want, because every single point is a precise point here. And you find your slope of your line, and you find y equals 15x. Okay? And 15 means it's 15 miles per gallon. That's what your slope means here, in this case, miles per gallon. How far can they travel on 11 gallons of gas? It's 15 times 11. And that's your answer. Okay? Number 3, they give you some data points here, and clearly this is not exact. It's an approximation. This is called a scatter plot, where they give you random points here, and they ask you, is it linear? Okay, well, it's close, but it's not exact. But if you notice, when they draw the points, it hits 3 of the points dead on, and one of them it misses too high, and one of them it misses too low. And so that's a very good approximation in that it hits 3 of them dead on, and it barely hits the other 2. That's a pretty good fit. It's not exact like the first or the second example, but it's close. So now they say come up with the equation of a line. So you pick any 2 of the 3 points that they hit dead on, and you can find your equation of a line that way. Number 4 talks about the amount of infections of HIV/AIDS cases in children. So in 2009 it was 2.5 million, and it was going up at 0.4 million per year. So they say let X years after 2009, so 2009 X is 0. So 0 is 2009 and your Y value is 2.5. And then add one more year to 2010 and you would expect 0.4 million more, so 2.5 plus 0.4 is 2.9. So here's your 2 points, 0, 1, 2.5, and 1, 2.9. You take your slope and you get 0.4, which is exactly what you got here. And so the rate of new infections is your slope here. Okay. And the fact that year 0 you got 2.5, that's your B. So you'd expect 0.4x plus 2.5, and that's exactly what you get when you do it the long way. Right? Now they say estimate in 2012. Remember, year 0 was 2009, so that's 3 years later, so you plug a 3 into this guy and you get 3.7 million. Number 5, it says find a linear equation that models the quantity y after X days. A quantity Y is initially 500 and increases at $6 per day, at 6 per day. So if it increases at 6 per day, M is your 6, and if it starts at 500, that's your B. So 6x plus B, 6x plus 500. A quantity is initially 1800, that's your B, and decreases at 25 per day, so minus 25 is your M, so minus 25x plus 1800. C, the quantity Y is initially 10,000, that's your B, and it remains constant, which means your slope is 0. And so that's Y equals 10,000, because you got 0x plus 10,000. Alright? So you got linear models where they give you, you got the slope and your rate of change, and we're used to dealing with that. And now we're modeling data by giving ourselves some points and sketching them and seeing if we can find an equation that fits the data. Alright, so 3.7. So they give you 6 different cases here, 7 through 12, and they give you 6 graphs here, A through F. And so they say college tuition from 2000 to 2012. Well, first off, college tuition is not going to be going down. It's going to be going up, right? So it's going to be going up, up, up. These 3 are going up. Now, it's not going to be negative, and it's not going to be 0 in 2000, so it's going to be some positive number. So this one has to be number 7. Okay, yearly average temperature at the North Pole. So it's the yearly average. It's one number, and so it's constant. So it's either C or D. Well, D is below the x-axis, and you would expect temperature at the North Pole to be cold. So it's 8. Number 9, profit from selling boxes of candy if it costs $200 and to make the candy. So that means if you sold 0 of them, you've lost $200 to start because you spent some money. So it makes sense that number 9 is A here, because they start out at a negative amount of money, having sold 0 items. They're at a negative amount. It takes them a certain amount of sales to break even, and then they start to make a profit. And number 10, the height of Mount Hood in Oregon. Well, that's a constant height. It's not changing, so it's constant, and it's a positive, so it's above the x-axis. So we'd expect number 10 to be C here. The amount of water delivered by a garden hose if it flows at a constant rate. Well, you would expect that to be increasing, right? And what do we have left? We got B and E. Well, we would expect it to be increasing, the amount of water flow. So you would expect it to be E. And then the sales of music CDs dropping from 2010 because fewer people are buying them. They're just downloading off the internet, so the sales would be falling. So that makes sense that that's number 12. Okay, number 13, state whether the ordered pairs are modeled exactly by a linear model. So if you go plus 1, and you go plus 2, if these are at the same increment and these are also at the same increment, then it's linear. And now they say if you got 2x plus 2, when you plug in these numbers, 0 and 2, 1 and 4, 2 and 6, yeah, each one of those is a solution to the equation, so it's exact. Okay. Number 21, state whether the linear model is exact or approximate. Well, it's approximate because you're not hitting each one. 19 is exact, 22 is exact, 20 and 21 are approximate because you're missing some points. You're not hitting them exactly. So 21 is approximate. Then it says find the equation with a line. So if you're taking this line here, you take any two of these 3 points that you actually do hit, and you use those 2 points to find your equation of a line. Okay. 23, this one is not hitting every point, so it's approximate. And what does this line look like that's going left, right at a horizontal? It's at y equals 2, just a constant line. Okay, now 27, it says find an equation line that models the quantity y after x time. So a quantity y is initially negative 5, that's your y-intercept, and it decreases at a rate of 20 per day. So minus 20 is your slope, so minus 20x, subtract 5. A quantity y is initially 8 and remains constant. If it remains constant, your m is 0. And if it starts initially at 8, that's your b. So b is 8, m is 0, so it's just y equals 8. Okay. 31 says plot the data. You plot each one of these points. And they say, could a point pass through all 5 points? And yes, it can. So sketch a line and determine the equation of a line. And you find your slope and your b and you plug it in and you got your answer. And you do the same thing for 33. 33, you find that it's close, so it's not exact, but you can do an approximation using this point, and that point to find your equation of a line. 29. Write an equation that models and describes the described quantity. Specify what each variable represents. All right, a barrel contains 200 gallons of water and is being filled at a rate of 5 gallons per minute. Okay, so if it starts at 200 gallons, that means your y-intercept is 200, and it's rising at a rate of 5 gallons per minute. So plus 5 is your slope. So let x be time in minutes, and y is the amount of gallons at time x. So y equals 5x plus 200. Right. 47. Mount Kilimanjaro is located in Tanzania, Africa, and has an elevation of 19,340 feet. In 1912, the glacier covered 5 acres. By 2002, the glacier melted to 1 acre. Assuming the glacier melted at a constant rate each year, find this yearly rate. So if you let year 2012 be year 0, year 2002 is 90 years later. So 0, 5, and 91, and you do the slope there, and you get negative 2 over 45. And you know that you start at 5, so your initial y-intercept is 5. So minus 2/45 t plus 5. So it says find the yearly rate. So it's decreasing at 2/45. It's decreasing at negative 2 acres per 45 years. Or you can say negative 2/45 acres per 1 year. You can look at it either way. You can say negative 2 acres per 45 years, or you can think of this as your number of acres lost, which is about 0.04 acres per year per 1 year. So you can look at it either way. Okay, and that's the answer you get there. 15, they ask you if this fits exactly. Well, if you plug in 1, you don't get minus 8. You plug 1 and you get minus 4. So it's not exactly. It's not on the line y equals negative 4. 51, gas mileage. It shows the number of miles of gallons traveled by a car on X gallons of gas. So X gallons and Y miles. Plot the data. Okay. Sketch a line that models the data. It looks like it's very precise. Calculate the slope. So you take any 2 points and you find your slope is 20. Your slope is 20 miles per 1 gallon, so 20 miles per gallon. And find the equation of a line. You plug in your slope and 1 point, and you solve it for y, and you get y equals 20x. Okay. So how far can a car travel on 7 gallons gas? 20 times 7, 140 miles.